Okay, there's something I left off for the subcontracting. Let's finish that very quickly, and then we'll go back to the observer pattern. Okay. Now, let me just go directly to the last bits about the contract redecoration. Basically, we talk about require else, ensure then. So now we talk about basically 4 different scenarios, right? Basically, we're talking about what if the require clause is missing from the ancestor. Let's say in this case over here, right? And also the second case we're going to see, what if the post condition is missing, the ensure is missing for the ancestor. And then we talk about the same 2 scenarios in the context of descendants as well. Okay, we talk about all the 4 cases. Okay, I think there's only one single case that would be a little bit counterintuitive. Apart from that, everything else should be intuitive. Okay, let's see the first one. This is where we got stuck at, well, myself particularly. Okay, so let's see over here, what should that be? Basically, what we want to understand is this is the ancestor, and this is the descendants. Okay, because that's the descendants, we gotta say require else, and then we have some Boolean predicate over here, new precondition. Okay, that's what we have. You can see over here we don't have anything here, nothing, not even require. Okay, so what we talked about what that should be. Okay, last time. If you don't have any precondition in the parent class, it's as if you say the following. It is as if you actually say class foo over here, and then F require something, okay, do and end. So that's not really relevant. We just talk about contracts. So for the require, it would just be true. Okay, before I talk about the consequence of this, let's first talk about why it should just be a required true. The answer turns out to be very intuitive because you can think about this particular fragment of code. Okay? This particular fragment of code has no precondition, has no postcondition. It's pretty much like how you will write in Java, right? In Java code, before you took this course, you don't really have much to write for pre and post condition. It's as if you left out all the pre and post conditions. In this case, what would that be equivalent to, right? In this case, if you didn't put any precondition for your feature, it's as if any input would be okay, rather than the other way around, okay? So now, you want to make sure you don't really remember the wrong thing. If you think about require false, okay, it's not the case because require false will be the most useless feature you can define for your clients because any input they pass will just be false. Okay, so now that's the first thing to understand. If the parent class simply don't have any precondition over here, it's as if they say require true. Okay, so now let's talk about a second question. What would be actually checked at the runtime? Right? If I give you something like this, we say it's as if we say require true. And then let's say we do have something over here we declare in the ancestor. What will actually be checked at the runtime? Do some simplification for me. We talk about the runtime check rule for iPhone. It's going to disjoint the preconditions in ancestor and also the descendants, right? So what would that be at the runtime? Okay, at the runtime, what we will check is basically true or new precondition, right? What would that be equivalent to? Okay, so what does that tell us very quickly about the sign issue over here? So that means when your parent class already got no precondition over there, as we say, as if they put true over there. In your descendant class over here, it is only supposed to make something more tolerant, right? Can there be anything that's more tolerant than true? No. So that means the disjunction over here simply say, because anything will just satisfy true at the parent's level. So now it doesn't matter what you put over here, there will always be just true, just be satisfied. Simply because at the parent level, we already make the input condition very tolerant. So the consequence is, it doesn't really matter what you declare this to be, it has no effects at the runtime. A very possible question could be, right, to test your understanding. We'll simply ask you about, let's say, for example, if I simply got x larger than 0, for example, right? If I simply put the new precondition at the ancestor level, sorry, at the descendant class level, is x should be strictly positive. Now, if I say, let me put something here, okay, for you. If I say B is of type bar, okay, the descendant instance, and then let's say before this, I can simply say check to see B dot x is, let's say, is equal to -1, for example. Okay, let's say that's the case. After this, if I say B dot f, am I going to run into contra violation for this? The answer is no, right? Because even though B dot f at this time, -1 being B dot x, would violate the x larger than 0 precondition. That's true. However, you got to see the context over here for the inheritance. Because now x larger than 0 or true is going to be equivalent to true. So it's going to be okay. Okay, that's a very possible questions that we might ask you. Guys, are we okay for this? Yes. The last part, yes. So now let's say this. Okay, let's say we got this new redeclare precondition in the descending class, x larger than 0, let's say. And then let's say we declare some instance of type bar. Okay? Let's say at the time we are trying to call b dot f, the x value, let's say an attribute, is simply just -1, let's say. It seems like -1 is going to violate this particular precondition at the descending class level. However, when you execute this, it is not going to give you precondition violation because what's actually being checked would be x larger than 0 or true, which is the implicit from the ancestor, right? That's why. Okay? Yes?
If you got rid of the else in the descendant class, what would happen?
Oh, if you simply do that, it's a compilation error. Okay, basically every time, I'll tell you why. The reason is, since when you say inherits from the foo and then redefine, whenever you have redefined the particular feature, then if you want to redeclare the precondition or postcondition, you got to say require else or ensure more then. Yes. Yeah. But I would say in the exam, if you forgot to say require else, that's okay. Okay, we wouldn't be so strict. Okay, but conceptually, you should know that whenever you're trying to have some precondition in the descending class, it's going to be disjoint with whatever you have in the ancestor class. Okay, good. Let's go to the next case, case number 2. Case number 1, talk about if the precondition was missing in the ancestor class, right? Let's now say the postcondition is also missing, right? You can see that there's nothing about the ensure, nothing, okay? So now we want to talk about what's going to be the consequence of that, right? So now, again, you can think about, the way to think about this is, it's just like how you wrote your Java code previously in 2030. You wouldn't worry so much about postcondition. It's as if any output would just be okay. It's the most tolerant postcondition ever. What's the most tolerant postcondition you can have? True. Okay? So this would be as if you say, okay, I'll say f over here, do ensure, okay, true over here. And okay, it's as if you have that. Okay, so now what's the consequence of this, right? So now let's do the same reasoning over here. But now since we talk about postcondition, let's say we got this descending class over here, and then we are redefining f. So now when we say ensure then, okay, and then we have a new postcondition over here. Okay, first of all, what will be checked at the runtime? It would be, logically, it would be whatever that comes from the ancestor, and should it be conjunction, right? Conjunction together with the new postcondition. So now, logically, it's equivalent to what? True? New post, right? Okay. Okay, that's just equivalent to new post. So intuitively, what does that mean? That means the following. At the ancestor level, we have no guarantee, we have no precise guarantee. We basically say anything you produce will be okay. But now, in the descending class, we are having a much higher standard. We're saying that whatever output value you produce, they must satisfy new post. Okay, it's a much higher standard. Okay, that's why when you use a conjunction over here, it turns out we just have to evaluate this new post condition. Let's do another check very quickly. Let's say over here in short then, let's say simply y, let's say y is the attributes, okay? Y must be strictly larger than 0, for example, okay? So now if you try the following, let's say again B is of type bar, okay? So now let's say we have no precondition, let's say, okay? So we simply say B dot F. Let's say for some particular implementation after this, B dot Y is simply evaluate to -1. In this case, are we going to run into any contract violation? We are, right? Because the fact that B dot Y is -1, -1 is going to violate the new post condition, which means this part over here is simply just false. True and false will give you false, okay? So this will give you post condition violation. It's kind of interesting because let me just try to contrast to you so you can think a little bit more. In this case, if you violate the post condition defined in the descending class, it's going to give you a post condition violation. On the other hand, in the first case, if you actually violate the precondition that's defined in the descending class, because we're using disjunction over here, you're not going to get any precondition violation. Okay, that's something you want to take into account. Okay, guys, any question here? Okay, good. So now, in the first two cases, we talk about what if the require and ensure are missing from the ancestor class. Let's talk about what if the require and ensure are missing from the descending classes quickly. Okay. Let's say this guy here. Okay. Again, we got ancestor class over here, and then let's say we do define some require over here, original precondition, and then let's say we go to the descending class. It's going to inherit through and redefine this particular feature. And let's say we simply don't have any require else. So now we want to ask, let's talk about precondition first. So it would be as if, let me just write something down and then I will ask you what that should be. As if F and then require else something. So what should be the question mark? I'm asking yeah, overall, we should really check the original precondition. I agree. But what predicate should be put over there such that once we put a disjunction, it's going to be equivalent to the original precondition? False, right? Okay, let's see this. Okay, this one is an interesting one. I'm going to make some source code available for you to explore that's illustrating exactly this case. Okay, so now it's as if we put false. You know what? It's better to put false in red. Okay. That's kind of interesting over here, because if you only look at this clause alone, having a precondition being false seems to make it completely useless. But no, because in this case we do have the context about inheritance, right? So what will be checked at the runtime? So at the runtime, what we will get is basically original precondition or and this guy here. And that's going to give us just original precondition, basically. Okay, so now that means we're simply just inheriting the original precondition, so that makes sense. All right, are we okay with this? Okay. Yeah, it's not that tricky, I would say, just want to think about the cases, right? Everything would make sense if you think about how things will be checked at a runtime, okay? Okay, final case. Let's say we do have, again, we got foo and bar, but now we do have the post condition declared in the ancestor class, okay, just original post, okay? And then we have inherits the same parent class and then redefine F. But now we have no ensure then, right? Okay, I'll write it down and then you tell me. So now as if, when we say F and do something, ensure then let me try to mislead you a little bit, okay? Okay, I'm telling you I'm misleading you, right? Remember when we talk about design, we're saying that original post condition tells us the standard on the output values at the ancestor class level. And what we should do in the descending class level, in principle, is to make the standard higher. Okay? So now, what would be the highest standard you can have? Highest standard. The standard is so high, such that basically no values can actually satisfy that as an output. False. Okay, so you might think about, oh, well, maybe I can just make it high standard, just highest standard, just false. This intuitively, this might make sense, but it doesn't make what? But in practice, this wouldn't work, because if you simply say ensure them false, that means when you try to evaluate at the runtime, what should you evaluate at the runtime? It's going to be original, post, and false, and it's simply just going to give you false. So now this feature again is very useless. Now in a different way. If the precondition is false, it's very useless for the clients, because any input they pass will just be violating the feature. But if you put the post condition to be false, it's simply too infeasible for the supplier to implement, because anything they implement, even if they give you an n log n sorting algorithm, you're still not satisfied, right? So now that means simply also useless. Okay. So now this is another way to go. Okay. So now this should just be true. Okay. If it is simply true, so that means the original post condition together with true, what would that be? Just original post condition. Okay. So you just get original post condition. So what does that mean? That means if you simply don't have any pre or post condition in the descending class, you simply inherit what you get from the parent class. Okay. But since we got some logic to worry about, conjunction versus disjunction, so that's why you'll be true or false, depends, right? So now we talk about 4 possible cases, right? You can see for each one of them, we talk about if the require or ensure is missing in either the ancestor or descendant class, it might be equivalent to either true or false, right? You don't really want to memorize them. You might just get confused. So more think about what's the logical reasoning behind that I try to explain over here. Has any question about any of the 4 cases that we talk about? That's something where I left off last time. Okay. Let me show you one more slide to conclude for subcontracting, and then we're done for this particular topic. Okay, that's about the contract redecoration rule, and we talk about the 4 cases. You can just look at them. Okay. On the slides, I didn't really illustrate too much about why it should be true versus false, but you can just rewatch the recording if necessary later when you review the slides for exam. One more slide I want to go over. Also, we talked about invariant last time. Okay, I'm going to skip this part. Okay, so now this is eventually what you have to review first for the exam. So basically, for this particular lecture here, we talk about what contracts really mean when you got inheritance in the play, right? Whenever you got inheritance, when we say you inherit the contracts, inherits itself is very vague. You inherit either by conjunction or disjunction, right? Depends. So now, in the general case, if you got original pre, original post, and also new pre and new post, okay? So now, there are actually 2 things you want to be able to do. Number 1, if I simply just give you the definitions for all the contracts over here, I might ask you now, prove to me whether the design is appropriate or not, right? In that case, we want to make sure for the precondition in the descending class, we make it no stricter. It can be just more tolerance. In the case of the post condition over here, we are trying to make the standard higher. Okay? Logically, that's how we translate into, right? You want to say the original precondition is stronger than the new precondition, right? The new precondition is actually weaker, allows more input to be passed. And also for the post condition, in the new version there, in the descending class, it should be higher standard. That's why it's stronger. Yes?
Is it possible to make the precondition stronger? Like I want my child to be stronger.
No, because in that case, it will violate the substitutability principle, right? You want to make sure. It's mainly about, I tell you what, it wouldn't make sense from a design point of view. Because, again, it's a very good question here. Let's say, again, let's say I'm using A here and B here. And then let's say we have a client over here. Okay, so this is client supplier. Okay, so A. So now let's say we have a feature F over here and a feature F over here. Okay, so now in this case, if you say in the child class, let's say we have no precondition for the parent class. Okay, over here you simply say require else. And then we simply got, let's say, x strictly larger than 0. The problem is, what's going to happen is, if you simply got, let's say, at a runtime, okay, in the client class, let's say A is of type A, okay? So now, if you simply say creates A over here and A, just dynamic type to be A, okay? So now, let's say this. Let me do the following. And let's say we can set the attribute. Let's say we also got another attribute here. Let me just make it complete for you. Also, we got set x, okay, to be some new x, some integer. Okay? So now after this, if I say a dot set x minus 2, and then if I say a dot f, do I expect any post-condition violation? Sorry, precondition violation. I don't. Because according to the API for f, actually, to be more precise, the static type is simply A. So there'll be no precondition violation. And let's do a little bit further. So now let's say, creates. Now, I'm going to keep the same static type, but now I'm going to give you a dynamic type B. Okay? So now, A dot set x also to be minus 2. Okay? So now, if I try to do A dot f, okay? So now, question for you. If I do that, what's going to be checked at the runtime? Overall, it'll be true, right? So now if you think about the precondition that's going to be checked would be x larger than 0, then now it's as if we put require true over here. So now this or this will just be true. So no precondition violation. But if we apply your logic over here to allow this particular stronger precondition to be checked, so that means what used to be passing is now going to fail. So you have inconsistency over here. So that's why it's disallowed. Yeah, just trying to illustrate the whole story. Either way, okay? I'm just repeating basically the same logic again. Okay? Why? Number one, logically speaking, you should not try to strengthen the precondition in the descending class. Number one. Number two, even if you do that at a runtime, disjunction is going to make sure as long as you satisfy the precondition in the ancestor class, you're going to be okay. Okay? Two things over here. Okay, so these are really the two points you want to get straight, okay, for the exam. Okay, so now we talk about static, just how you can prove things. What about runtime stuff, okay, dynamic stuff? At runtime, we know that we're just going to use disjunction even if new precondition is stronger, even if. It doesn't really matter because disjunction will make sure if you got an original precondition or something that's stronger, it will still be the original precondition, right? The same. Okay, similarly for the postcondition over here. Okay? Okay, that's a very quick summary of what we have talked about this class and last time. Any questions? Yes? Never mind? Okay, you can ask me later. Okay, that's about the two parts you have to know. One at the static time, one at the dynamic time. Okay? Okay, if no questions, I would like to move on to observer. Okay, let me review very quickly the problem we have. Okay, I'm hoping that today at least I can show you the first attempt for the design, and I'm going to show you the observer. And hopefully we can talk about the disadvantages for the observer, even though it works already. Let me just say again, so this could be one potential problem we have. Basically, you have some so-called subjects, okay, like a weather station. They produce weather data, temperature, humidity, and also pressure. And let's say we got 3 different apps. Each one of them is going to somehow observe. Well, I'm using very general term over here, nothing about the pattern just yet. Each of the app is going to do their computation according to the value of certain measure for the weather data. For example, okay, for simplicity, we assume for the weather data, we got temperature, we got humidity, we got pressure, okay? And then we got weather data over here. Basically, for each of the apps, they have to periodically update their display according to the latest measure, right, for the 3 data over here. For example, let's keep this in mind for this lecture here. So let's say we have one app for the condition. Condition is just going to tell you the temperature and also humidity. Okay, just these 2 measures. Just tell you what's the current condition for the weather. Number 2 is about forecast. Even though we say it's forecast, it's a very simplified model we are applying. Okay, basically you're maintaining the latest pressure and the current pressure. If the pressure has been decreasing, that means it's likely to rain. Okay, otherwise it's not likely to rain. Okay, just using pressure. And then the 3rd app we have is called statistics. Basically, you just want to calculate what's the minimum, what's the maximum, and what's the average for, let's say, temperature. Okay, now let me say one more thing. App number 1 for condition relies on temperature and humidity only. They don't care so much about the pressure. For forecast over here, they only care about pressure. They don't care so much about temperature and humidity. All right? For statistics, they only care about temperature, but not the other 2. Okay? So we got 3 apps over here to develop. So now, what can be done to implement this for each app? The most naive solution is to say for each one of them, for each of the app, they simply maintain a reference to the weather data objects, right? However, the weather data objects might remotely reside on some geographical location that's very far apart from the app. So you might need some network connection over there. Let's take that into account as well. Okay? Let me show you a very naive solution, which you might do as well. Okay? That might work. So now, in order to show you the design, let's go over this design diagram for the first one. Okay? Let me just switch this guy here to here. Okay? Okay, let's learn about this particular design over here. Okay? Again, before I show you the code itself is very easy to understand, but let me show you the design first, the architecture. Oh, by the way, first of all, there's no inheritance over here, as you can see. Only client supplier. Okay? Only the green arrow, client supplier. First of all, we have a class called weather data over here. Okay? It's effective. Okay? And then we got the 3 measures over here, temperature, we got humidity, we also got pressure. Okay, they're all real numbers. And also we have some helper feature here tells us, given the temperature, given the pressure, given the humidity, return true if all the measures are within their correct limits. So there's got to be some certain minimum and maximum value for each one of them. So that can be a nice invariant we can write. So this one here is really important, right? So whenever we talk about class invariance, that means under what circumstances can a weather data be valid? In this case, as long as the correct limits query evaluated true, all the 3 measures, that means it's valid. Okay, that's about weather data. Okay, any question about weather data? Okay, that one's easy. Okay, and now we want to see how we can make connection to the weather data. Okay, let's take one of them as an example. Let's say we have the class called forecast over here. Okay, so for the forecast, first of all, we have a client-supplier relation over here. Okay, that's client-supplier, and now the arrow is over here. So that means which class is a supplier? Weather data. Good. Okay, just make sure you understand that. Okay. Okay, so that means over here, let me just make a notes. So this is supplier. Okay, and this part is the clients. Okay, so now let's see this. We're going to see a little bit more details later, but for the forecast, you simply got a feature called display. Okay, we just make it simple, which means whenever you want to display, it's going to get most up-to-date weather data. Okay, and then it's going to maintain two measures. It's going to say what's the current pressure and what's the last pressure. Basically, whenever you get the latest pressure, you assign the current one to the last one first, and then update the current one. Okay. Basically, you want to see whether you always compare to see how these two numbers are related, right? If the current pressure is actually smaller than the last pressure, that means it's decreasing, so it's likely to rain. Okay, very easy implementation. Similarly, okay, so we got another one. It's called current conditions. The same. We also got a client supplier. Okay, it's also called weather data, and also we got a feature called display. Okay, for all the three apps, display. And now for current condition, we only worry about temperature and humidity. Okay, only these two. And we got statistics, the third app. And now we also got display, and also we only worry about temperature. Okay, that's kind of the architecture we have. No inheritance, we only got three client-supplier relations over here. I'm just trying to show you the diagram here, so when I show you the code, it's easier to understand. Okay, guys, are we okay for this? So that's only about the, more like the supplier side for implementing all the apps and things together. We're going to see how we can have another client who's going to use this particular first design. Okay, we're going to see the tester in just a moment. Okay. Before that, I would like to show you quickly how the code will look like, very quickly. Okay. So now let's see this. Okay, so basically for every app, let me read this to you. Whenever the display feature is called, you want to retrieve the current value for temperature, humidity, and pressure. Okay, so now that's the thing. What timing should it be for you to update? That's the question. Should you do that every time you try to refresh the display? But what if when you refresh the display, there's actually no change on the weather data? That's a question to think about. Okay, let me repeat again. For you to evaluate the first design, you want to think about basically for the display feature, which I'll just show you in a moment. Every time you want to update it, refresh the display, you're actually forcing yourself to actually go to get the latest weather data remotely, possibly. However, it might turn out you didn't have to do it because the weather data has not changed. For example, the temperature remained the same as 5 seconds ago, so there's no need for you to really do that updates. Okay, so you may have wasted some resources, maybe. Yes. Oh, good, yeah, good. Well, that's good. So now somehow you can see all the apps over here, they're somehow very aggressive, right? We'll rather let them be very passive, which means they will only be updated when there's an updates on the weather data side. We'll see. Okay, but we don't see that in for this first design. That's a limitation. Okay, let me go through the code very quickly. Okay, I also will make the source code available to you. Okay, so now we got weather data here. We got temperature, we got humidity, we got pressure. Okay, so now let's say I would say this is really the most valuable part for this particular class because you're trying to define what does it really mean for a weather data object to be valid. In which case, it declare class invariance. Okay, we just got some measure over here, and we simply say, what does it really mean when the result is actually true? In that case, it should be the temperature, pressure, and humidity should be within certain limits, right? And now, we can say that before you try to construct a new instance for the weather data, you make sure the precondition says that they should be the same. They should be within that range. Similarly, for the invariance, we also say that it should be correct limits, always. As soon as you have any number that's outside its particular range, it should be an invariant violation. Okay? Questions about the first class? Okay, we have just gone through the code for the first class over here, right? Let's have a look. I'll just show you one of them. How about that, okay? What about just forecast very quickly? You can see others by yourself. Let's say for the forecast, Basically, for the attributes, we got current pressure and also loss pressure. Okay, so these are the app-specific attributes we are maintaining. And now for the weather data, it's simply like a reference to the weather data. Okay. Again, the weather data objects may be in the same computer. It may be on a different computer in the same building, or it might be in a different computer thousands of miles away because of weather data. Okay, so there might be some remote procedure call you have to do. Okay. So now for the commands over here, let's say we have a constructor. All we make sure is after you, whenever you try to create a new forecast app, all you got to do is to pass the reference for the weather data. That's all you do. So after creating the instance, the weather data for this particular forecast objects is going to be the WD we are passing, right? That's the most important part to understand. So as soon as you create the app objects, you're making a link to the weather data objects, either local or remote, doesn't matter, okay? So now, updates. So now let's, update simply means we want to update the measure on which we are trying to do the computation. So now, once we say updates, first of all, we say loss pressure should be the current pressure, so we can have some comparison. And then the current pressure should be whatever the weather data is, what's its current pressure. So now, for the first design, you want to pay attention to where exactly we do the updates. Okay? So this update feature is going to be called just within this particular class. How? If you look at the display, you can see whenever we want to refresh the display for this particular app, we have to do an update first. Even though there may have been nothing to update since the last updates, if you see what I mean. Okay? So now, after the updates, presumably we got the most up-to-date data for the pressure. After that, we can simply just try to do some computation, right? We can say if the current pressure is larger than the last pressure, in that case, there's no rain. Well, it's increasing our pressure. Otherwise, we can say maybe the rain is coming. So now, the most important line to pay attention to, let me recap. And then for the other two apps, I'll let you read them through. It's very similar. Okay, so now the first line is, whenever you create a new instance for the forecast, you want to make sure you link to some weather data objects, number one. Number two, whenever you try to refresh your display by calling the display feature, you have to call the updates. Otherwise, you have no assurance that you're really calculating based on the latest data for the weather. Okay? So these are the two most important parts to pay attention to. Questions? We okay? Okay, so now if you look at, let me just go through, okay, in just a few seconds. If you look at the current conditions, it's just the same. So now the key thing to pay attention to will be, we are also going to make a link to the weather data, okay, for the current conditions. And also for the updates, which is updating different attributes, okay? But I still have to use the weather data that in order to make your updates. And then for the display, you also have to say update first before you do anything further. Okay? That's about how you define the current conditions. In fact, for any kind of app you want to support using this particular design, the skeleton will be just the same. You always have to make sure you connect to the weather data objects. And also you want to make sure you update whenever you update the display. Similarly, for the statistics, the same as before, you just got different attributes for the app-specific calculations. And also, after constructing the instance, you want to make a link to the weather data, right? And also, you want to update just different attributes as before. So now, for display, you just update first, okay? The same as before. Okay, so now if you look at that, that's exactly the design we talk about. So now we have seen the architecture for the design, and we have also seen the code for implementation. Any questions? So now we want to actually look at how to use this particular design. Hopefully from there we can see drawbacks for this particular design, which is important to realize. And then we move on to a better design, which is observer. Okay? So now if we go back here, so now let's have a look at the the code over here. It's basically weather station like a client for the design. Okay, we're gonna manipulate the weather data objects and also the three apps objects. Okay, let me show you. How about maybe I should go to the test code directly to show you. This might be a little bit too small. Okay, what I will try to do is, okay, how about this? Let's do that here. Okay, let's have a look at what we're trying to do over here. So now we're just trying to illustrate how to use the code we just defined, the design. So we got weather station over here. Okay, so now we got current conditions, we got forecast, and also we got statistics. Okay, so these are the three different apps we can create. And also we have a single weather data, just a single one. Okay, so now let's have a look. Line number 1, we are trying to create a new weather data. So 9, 75, and 25. Okay, basically we're creating WD over here. The initial measure is simply 9, 75, and 25. Okay, initial ones. No connection just yet. And then we're going to see this creates. When we say create CC, which is current conditions.make. And then we're passing WD, which is this current object over here. Right? If you look at the definition very quickly, I'll show you one. Basically, you can see that this is the constructor we are calling here. Right? So WD will just be replaced by WD, which is this object over here. Right? And then we are saying that the weather data attributes for this particular objects should be assigned to, sorry, there's a typo. That should be just WD. If you look at the slides, it's fixed. Okay? So what does that mean? That means the following. So now when we create this particular current conditions app, its weather data is simply just going to point to this particular object over here. It kind of corresponds to the design diagram when we got a client-supply relation. Pretty much corresponds to that. Okay? And similarly, if you try to do forecast and also statistics, the same. Okay? For the forecast object, it's also going to point to the same weather data objects. And also for statistics app, it's also going to point to the same weather data objects. Okay? That's what we have achieved so far. Okay, are we okay up to now? Good. So now let's see how things will go. And then you tell me whether that's a really good design or not. Let's say this. Let's say we want to change the measurements. Let's say we want to simply change the measurement for WD to be 15, 60, and 30.4. Okay? So now if we do 15, 60, and also 30.4, it seems like an update is necessary, right? That's okay, because every time when you're trying to do display over here, let me use orange. When you say cc.display, if you look at that, so that's a current conditions. If you look at the current conditions class, before you try to do display, you always have to do an updates, right? Every time before you do any display refresh on any of the apps, you always have to do updates. So that means when you do cc.display, it's basically going to make a connection to this particular data and then look for what it needs. For the current condition, you only care about the temperature and humidity. All right? So now it's really about whether this particular connection is really necessary or not. In this case, it is, because we just updated the measure to be 15, 60, and 30.4. Okay, that's okay. And then similarly, if you do fd.display, similarly, if you go to forecast class, okay, if you go there, the forecast class, before you do display, you also got to do updates, similar. Okay, so now that means you also have to get a fresh connection to the objects over here. Okay, and similarly, if you do sd.display, you also have to get a fresh connection over here. So far, so good. So far, it seems like there's no waste or redundant updates. Let's say 5 seconds later, let's say your app updates your display every 5 seconds. Now, what's going to happen if we should do cc.display, fd.display, and SD the display. So now what does that mean? That means for CC the display, so now that means we're going to follow the same link and inquire about the latest states for the weather data again. And similarly for FD, you're also going to inquire about the latest value. And also for SD, it's also going to require the latest value. But now, are the green connections here really necessary though? They are not, because you can see that in between the orange and the green, you can see in between over here, no change on the measurements. That means the updates are redundant. The second updates, the second one. Okay? All right, so are we okay for this first design? That's really the main drawback over here, because somehow you might just make too many redundant connections to the weather data, which might be remote. In that case, if you make your redundant call too frequent, you're basically wasting the bandwidth of your network traffic. Of course, network is kind of beyond the scope for this particular course, but I'm just mentioning the context to you, right? So it's may not be the best design you want to have, because it's relying on just how frequent you might refresh your display, rather than how frequent the data itself would change. Okay, let me write down some remarks for you. Okay, hopefully you see that. So the main drawback over here is the current design updates according to the frequency of this, according to the frequency of display, rather than according to the frequency of data change. Yeah, do think about this particular remark over here is really important. Data change. Because the observer pattern is going to change exactly this. Okay? Did you have a question, or? Yes, you. Go ahead. What to be a feature? What do you mean? Oh, you're saying that just updates feature alone, but you don't really call the update in display. Here's a question. Okay, I see what you mean. Tell me if I understand you correctly. Let me go back to the design over here. Okay, again, that's our design. You're basically saying that for the display feature for every of the app, you're going to get rid of this line. Am I right? Sure. Question for you. Then when would you do the updates? Should you do every 5 seconds? Should you do every 10 seconds? Should you do? But how do you know the data actually change? I tell you what, from the app's point of view, they wouldn't know there's a change on the data until they actually request the weather data. But as soon as you find out there's a change, it's too late. Well, as soon as you find out there's no change, it's also too late. That's a problem, yes.
What if weather data itself, whenever it had a change, it updated?
Aha, that's exactly right, yeah. So basically you can see, the problem is we only got unidirectional interaction over here. Every time, it seems like every time we need to display, we simply go this way of interaction. However, the frequency may be redundant. We want to go the following way. Every time if there's any updates on these 3 variables, we want something to go this way here. We want the interaction to be the other way, which means the update feature should only be called not within the class of the app. It should be called from maybe the weather data itself, which means we make the remote procedure call only when necessary. Okay? If that makes sense to you. The fix you suggested wouldn't solve the problem, because if you simply got rid of updates from the display, the problem is you got to call updates somehow, right? Without having this direction of working over here, you simply would just have something that simply get out of sync with the weather data. very easily. Okay, that's why. Okay. Guys, any questions about the first design? It's actually quite a nice flow over here because whatever drawback we have in the first design, we're going to improve it into observer design. There are some good parts about this. For example, the invariance we see, right? That's a good part. We're going to keep that. Okay. Okay, if there's no question here, what I will do is, okay, we got about 30 minutes. That's good. At least I can finish observer design today in complete details. And then we'll move on to a third design, which is even better. Okay. So now what I will do is I will go to the observer pattern. So now we have abandoned the first design, which is not so great because we might have redundant updates that waste our network resources. So now let's talk about observer pattern. And this one here is going to improve the matter. Let's see exactly how. I'm going to present the observer in two different diagrams. The first diagram just tell you in principle, these are the classes you should have. Okay? The second one, I'm going to instantiate the observer pattern into one that's specific to our weather station data. Okay? Let's do the first one here. Okay? Again, your favorite concept about polymorphism and diverse binding will come back. Okay? We need that in order to define the observer pattern. Okay? So now, if you want to define the observer pattern, you basically, usually you just got two clusters or packages. You got subjects, you got observers. You're not restricted to just a single observer. You're also not restricted to just single subjects. Okay? It can be many observers and also many subjects. Okay? Now, but typically, it's a single subject versus many observers, typically. So now we got subjects over here, which is effective. And also we got observer over here that is deferred. Okay, we will talk about why it's deferred in just a moment. Okay, and then you can see that over here for the observer, you will typically have some update feature, like in our app, right? We also got an update feature. Okay, it corresponds quite nicely. And also we got some helper feature, just tell us whether the data are most up to date with the subjects. Okay. So now, what's really important for you to see is this particular declaration. So we got observers, which is a list of observer. Okay, so now I claim that this observers list is polymorphic. Why? Polymorphic. Exactly. So at the runtime, we know that observer is going to collect all the descendant objects from the observer class, right? Observer itself is deferred. Okay? We're going to see that in just a moment. Okay, observer, okay. And also, what you talk about how to notify. Basically, you just talk about notify concept. Okay? So we also have a feature called notify. Okay? Notify is actually quite easy to implement. We'll talk about this in just a moment. It's a very easy implementation to have. Basically, the idea about notify is this. The notify is actually going to go through all the so-called attached or subscribed observers for this particular subjects, go to each one of them and call their update feature only when necessary. Okay, we'll get there. And then the post condition for notify is like this. Okay, let's try to have a look at that quickly. The post condition for notify is for every observer objects in the observers, right? We want to make sure they are simply up to date with the subjects. Up to date simply means maybe their temperature is up to date, the humidity is up to date, etc. Okay, under subjects we may have more than one subject, but typically just one, typically. Okay, but we'll see the more general solution in the third design. And also for observer, we also can have as many observers as you like. In our case, it would be 3 observers. So this is a general outline for observer pattern. Okay, so now let's see how we can instantiate this principle here for the observer pattern into our example. Quickly. Okay, you can see they basically follow the same hierarchy here, the same. Okay, let's see this. So we still have our subjects class over here. We still have our observer. So now there's only a single subject's descendants, which is weather data. Whereas we got 3 observer descendants, we got forecast, we got current condition, we got statistics.
And now let's go right to the points to see the bidirectional interaction. So what we have is, first of all, you can see observers is a list of observer, polymorphic, right? So now let's see this. Let's see the old client supply that we understood already. We're basically extending what's being discussed in the previous design. From forecast, we have some weather data. Okay. From current condition, we also got some weather data. From statistics, we also got some weather data. Okay, all of them, the same as before. But now, this is really the key thing. So that means we got another direction of interaction. So what does that mean? That means for each subject, we have the option to attach or detach a particular observer to that particular subject, such that, let's say, if the forecast is already attached to this particular subject, it's guaranteed. When you call notify, you call notify only if there are certain updates on the measure. Okay? When you call notify, it's just going to notify only the observer that's currently in the store only. Any observer that has been detached or has not been attached yet, they will not be notified. And how exactly do you notify? We'll see. Well, to make it short, the way you notify is by calling the update feature for each of the observer that's attached. Okay? Any question about the architecture over here? Okay, I hope I'm not going too fast. The architecture for observers is actually not too difficult. I think the main thing for you to understand is, in the previous design, we only got one direction from each of the observer to the subjects. That's what we have. Now we're extending it to say, from the subject, you also got another direction of interaction to observer. We're introducing some more dependency here. Okay? But also the array or the list is polymorphic. Okay, if you have no questions, I would like to show you some code over here quickly. Let's see the code. Let's go from this side over here. Let's show you the subjects and also the weather data. Let's see exactly how these two classes can be defined quickly. And then we'll see some tests. Okay, so that's about our first design. We have done that already. Okay, by the way, if you go through a slide, that's exactly about the drawback for the first design. And now this is how we are trying to improve for the second design. There are different terminology people use for the observer pattern. So people might say attach versus detach, subscribe versus publish, or register versus notify. Right? Just got different terminology. Okay, I might just use any one of them. Okay, so now the most important thing is now in the second design for the observer pattern, we only update when necessary. Okay, we only notify when necessary. But let's see why, how. Okay, that's the. So now one thing to note. Typically, when you use the observer pattern, you use the one-to-many. One-to-many in the sense that you got one single subject and you got many observers. We're going to see that this might be quite a restriction in general. Because in general, you shouldn't really forbid the possibility of multiple subjects and multiple observers. In that case, things might get a little bit too complicated that we may want a better design. But let's not worry about it just yet. Let's say we got a single subjects and many observers. That will work quite well for this observer pattern. Okay, observers basically, or subscribers, they are attached to a subject. Okay, I'm just talking about things informally. We'll see the program code in just a moment. And also, the subject notify the attached observer. You can see attached, not all the observer, only those that's attached to the subjects. Okay, and then, okay, just about vocabulary. You can read them through. Okay, any questions so far before we see the code? Now, let's have a look at the code quickly. So now, let's first look at the subjects over here. Okay, subjects. The subject looks like this. So now, first of all, we declare the attributes for observers, which is a polymorphic list over here. As you can see, it would be a very bad design. Let me ask you this. What if I modify this declaration over here to be observers is a list of forecast? Why would that design be bad in that case?
rather than observer. Yes. You're not quite. You want to be very precise. Basically, I'm asking this. If I change the decoration over here, okay, let me just go back to my iPad here. Let me tell you exactly the change I would like to make. Okay, so this is our subject over here. I'm asking the following. Rather than having a list of observer, I'm simply picking up, let's say, forecast over here. Okay, I'll simply say forecast. So what's the consequence of this that I may or may not like?
Both forecast objects, so instead of being a superclass, it's going to be.
Yeah, exactly. Yeah. So if you do that, that's exactly right. So if you have only forecast over here, that means only forecast and its descendant classes can be stored into the list. In this case, what forecast is already the bottom of the hierarchy. So now that means you cannot store current conditions, you cannot store statistics either. Okay, it's a very simple design question here. So every time when you declare the, every time you want to declare the type for your collection, you want to give the most tolerant type for your purpose. Okay, that means that's close to what you meant to say, I guess. Okay, so now let's go a little bit further. Let's now try to see some code. Okay, polymorphic list over here, and now we do the make. So now, how do we write some contracts over here? Anybody want to help out? Let's say after creating a new subject, simply no observers just yet to begin with. What should be the contract for that? List is empty, right? Or list account will be 0, the same. Yeah, it's empty also fine, okay? Okay, simple contract to write. And let's say we try to attach. Oh, here's the thing. So this is something new. This is a very important feature here. So that means once I create my subject to begin with, the list of observers is simply just empty. I can add as many observers as I like. Let's say there's no bounds. So now I'll simply say attached some observer. So now what can be the contract to write? Precondition, let's say. Well, precondition could be, for example, you'll suggest something. Well, if you don't believe there should be any precondition, just say no. What if the same app is trying to subscribe to the weather data for twice?
So it shouldn't already be.
Yeah, exactly, right? So now you want to make sure, first of all, you want to make sure not yet attached, right? Well, easy. Just say not the case, observer.has. Oh, okay. Just say make sure it's the object is not there already, the observer. Okay, and now symmetrically, what should be the ensure is attached? Well, take out the negation. Okay, very simple contract to write. Yeah, for this contract, of course, don't memorize them. You know, it's very intuitive. You want to think about what's kind of the input condition and what's the output condition for pre and post condition, right? Up to now. We're almost done with the course. Hopefully you're now more comfortable with writing the contracts, okay? Not yet, getting there. Okay, so now, also we got detach, okay? Detach will be completely symmetrical, right? So now if I want to detach a particular observer, I better make sure the observer is there. Okay, it's already attached. Once I detach that, it should not be there anymore, okay? Easy to write. Now let's come to the most important feature over here, which is called notify. Okay, what does notify do? Basically, let me read it out to you. Notify each attached observer about the updates. For example, if the weather data object that's being observed has changed on its temperature, I want to notify every of my attached observer doing updates. So you can see this is on demand. I only call notify when I need to. Okay? I don't need to call notify every 5 seconds or something. Only call when I need to. Okay? So now anybody want to suggest to me how to write this notify over here? Let me give you a little bit space over here. Basically, we talk about here, we got class subjects, I believe. And then we got observers.
which is a list of observer. Okay, we got attached, we got detached. And let's say we got also modify, which is a command,
which takes nothing
as input.
Anybody want to suggest how to implement this quickly? Yeah, I agree. How about we do across? Across what?
Sure, let's do that. It's a good exercise for you. You haven't done across for a while, I guess, except for your project, right? Across observers as, how about
OB? How about that? Observer. Okay.
And now, what should we do?
Well, you don't have to check if the observer exists because you guarantee when you go over the list, only those that exist will be attached, right? So now, question for you. Remember, for the across, we can either use loop, or sum. What should we use? For the across, we can either use loop, we can use or we can use sum. What should we do over here? Okay, well, basically we want to loop over, right? Also think about we are now doing this in the implementation. Typically, you only do sum or all, typically in the contracts. Okay. Let me just do this, and then I will take more inputs. Okay? I can tell you there's only a one-line implementation here. Okay. Okay, so what should we do? OB is a cursor to observer, right? So when you say OB.item over here, we know that the static type for this observer. Agree? Okay, let's get it clarified first. And you're right. So now that means we can call any feature that's defined in the observer class. Okay, so now let's have you cheat. Update, right? You can see the update even though it's deferred at the observer class level, but it's guaranteed to be implemented in every of the descending classes that's this dynamic type. So we are fine. Okay? So now it should be the updates. Dot item and then dot updates. That's all we do. You can see that this notify feature will just be initiated by the subjects, not the observer. So that means it can be as frequent as it is necessary. Okay? Any question about this? Let me say one more thing. Basically, at the runtime, what's going to happen is this. It could be that you have your observers, let's say observers list, that's simply pointing to, let's say two things. Let's say two observer. Let me just give you one example. Let's say somehow we attach the first one to be a forecast. Okay. And the second to be, let's say, current conditions. The dynamic type for these two objects are different, right? One is forecast, the other one is current conditions. So now, question for you. Apparently, we need 2 iterations for this notify, right? 2 iterations, right? My question is, for the first iteration, which version of updates am I going to call? Forecast, right? Forecast, if you look at that, let me refer back to you quickly, okay? If you have a look at the forecast updates, okay, we're reusing the logic from first design, that's okay. That's the part we can reuse. If you want to call the updates for the forecast, you're just going to update the current pressure and the loss pressure. It's one version, specific to the forecast. On the other hand, if you try to do the second iteration, we're going to call which version? Current conditions, right? For the second iteration. Now for the current conditions, let's see quickly. For the current conditions, we're going to execute this particular version, right? Which is going to update the temperature and humidity, right? So now that's dynamic binding. Okay. Again, you can see we have seen polymorphism and dynamic binding for so many times for the design pattern. That's why it's really important for you. Okay, so update over here, that's dynamic binding. Yes.
Should we check that we should update that particular observer? Because if we're going to
I see what you're talking about, more fine-grained notification. That's something we didn't really talk about over here. Yes, for sure. You may want to say, if let's say from the subject's point of view, if I'm only updating, let's say temperature, maybe I will only selectively choose those observers that use the temperature. Yes, you may do that. But for now, we're just making it a little bit more general. It's already improved by already, right? Because you only try to do updates when necessary. Yeah. Good, that's a good question. However, once we move on to the third design, you will see that whatever you're wondering about, you'll be resolved. It's will be much more fine-grained. Yeah. Okay, that's about the notify. Okay, and then also there's a post condition over here. So now, when we do the post condition, we're saying universal quantification. We say, make sure after executing notify, every observer that's attached is now up to date. Okay, you can look through the up to date later. Okay? Okay, we got 10 minutes. So now let's say weather data. How do we do for the weather data? Weather data is pretty much the same as before, right? Basically, we're talking about, we have just finished talking about subjects. Let's now talk about weather data. Okay, that's what we'll do. For the weather data, okay, we still got the 3 measures as before. But now, what we want to do is, oh, by the way, there's something you can do over here. Because I inherit from the subjects, I can rename the make as make subjects. That's also something you can do. Okay, it's not really critical, but you can rename the constructor at this particular level if you like. Okay, so now question for you. Where should we call the notify? We don't just call notify, right, autonomously. There's got to be some feature that will trigger notify. Let me give you a little bit of hints over here, okay? Basically, what I'm asking is, if you look at the first design over here, okay, that's the first design. Let me give you more hints over here. Okay, if you look at, this is the tester that we went through for the first design, okay? So now you can see that, let's talk about the weather data, because currently it's a subjects, right? Should we call the notify when we first create the weather data objects, or should we call the notify when we set the measurements? We got 2 possibilities there, right? Where should we call the notify here? Set measurement. Why not the make? Not too, well, something about the post condition for the make. Remember what the post condition is for the make. Empty observers, right? Because initially there's no observer in the list just yet, so we have there's no need to notify anybody. Okay, that's a slight point there. Okay, so now we're going to basically extend the set measurement over here by saying whenever you set a measurement, that means you're changing the values. In that case, you're going to call the notified. Okay, that's really on demand. Okay, so now if you go back to where we were over here. Okay, let's go back to the slides. So now you can see for the set measurements, you're simply just going to call notify. I didn't really put it here, but under set measurement, it should be notified. Okay, it should be. Every time you try to change the measurement for the weather data, there should be a notify being called. There should be. Okay, I should have put it there. Okay. Now, what about the observer over here? Observer is very easy. Okay, you can now see that we don't have to really update ourselves periodically in the display. We don't have to. That's the only change. Okay, if you look at that, you can see that over here for the updates. First of all, for the observer, let me just show you the architecture again. So first of all, we talk about this particular observer over here, right? We just have to make sure updates deferred, and also this is also deferred, right? Just about what do you really mean by up to dates, right? Observer itself is very easy. You just have these 2 features here, and they are both deferred. And now, for each of the descendant classes, we're going to make these effective. But how? Let's see one of them. Okay, basically you can see that each effective descendants of the observer, there's a typo here, I should really change that. The observer should define what weather data are required to be up to date. Okay, and then also
how to update it. Okay, so these are the two things we want to define. Let's just take the forecast, for example. If you look at that, it's going to inherit from observer. Okay, and then we're also going to create a new observer here. So now a question for you. Now, when we want to make a new instance for the forecast, what should we do over here? What we did in the first design was like this. Let me just go back here and show you. If you remember from the first design, when I first create the forecast app, I want to make sure its WD is really pointing to this particular weather data. That's all I did for the first design. Now, in the second design for the observer pattern, should I do more or less or the same? Basically, you want to make sure when I first create this particular observer app, not only that, I'm going to make a reference to the weather data. At the same time, I want to attach myself to the subjects, right? Now, how do I do that? Okay, let's go to this particular architecture over here. Okay, so now basically I'm talking about how we can define the make feature here. Let's see this. Okay, let's say we got a forecast over here. Okay, forecast. Let me just show you over here. Okay, so I'm just going to have put a code here. How do we create the make? Let's say WD, which is weather data. Okay, so now what should we do over here? One thing we can do is to say weather data the attributes weather data is simply assigned to WD. Okay, it's basically handling this particular direction over here, right? So maintain a reference for that. But what else? We should do one step more. We want to make sure the current app we are creating is attached as one of the observers of WD. That's the most complicated step for the observer pattern. But how do we do that? Programmatically. Anybody? Well, you got everything you need. You got all the API you need, basically, over here. Should I start you with WD dot? Somehow I want to subscribe this particular forecast object over here to be one of the observers. Yes, go ahead. You will use attach. Exactly here. And now, statically, what should be the type that will be taken for attach? Observer. Good. So now, what should we pass dynamically? I heard the right word. Current. Or like a this in Java, current. You know what current is, right? Good. So this is the extension we have. Okay. Now, so we are basically ensuring bidirectional attachment. Okay. We want to make sure the forecast is maintaining a reference to the weather data. At the same time, weather data has the forecast as one of its observers by attachment. Okay. So these are the two lines. Okay. Okay, that's why we have over here. It's really important. Okay. So now, after that, we can make sure. So you can see not only that weather data is a weather data WD. Okay, and also the observer has the current. Okay. Okay. So now we can also define up to dates. Okay. Up to date, which is about the pressure. Okay, the pressure is the same. And now, here's the thing. We still have the update feature in the app. However, one thing to notice is now we don't really call the update feature in the display anymore. All we do is we simply say display. We don't really call the update as a first step, unlike the first design. Because now we are pretty sure every time if there's a change on the measurements, the weather data is going to notify all the attached observers. So the update should not be called within the display anymore. Okay? It's a very important change to notice between the two designs. Guys, are we okay? You awake? I hope. Okay, if you look at that for the other two, let me go through the other two very quickly, and then we're done. If you look at the other two, we do the same thing. You want to attach the current, okay? And also, you don't really call the updates in the display anymore, okay? Again, we got to notify from the subjects. Finally, we got statistics, and also we try to attach the current, okay? And then after that, we also don't call the update anymore in the display, okay? That's about the observer pattern. Okay, I will stop here, and then from Wednesday, I will go from the tester to start with, okay?